What integer is equal to the square root of 10 squared plus 2 times 10 times 11 plus 11 squared? 10 squared is 100, and then 2 times 10 is 200 times 11, I believe, would be 220. And then 11 squared is 121, all under the square root sign. And then this is 441, and then the square root of 441 is 21. Two vertical trees are 5 and 15 meters tall. The bases of the trees are 24 meters apart along the horizontal ground. A bird flies from the top of the shorter tree to the top of the taller tree along a straight path at a constant speed of 4 meters per second. How long does it take the bird to complete the flight? Well, let's first just draw this parallel line, and that of course will still be 24, but this distance here will be 15 minus 5, which is 10. So then if I call this, whatever you want to call it, distance, you can use Pythagoras. D squared is 10 squared plus 24 squared, right? And then when you calculate D, it'll be 26. And then you use the formula speed is equal to distance over time. And we have been given the distance, well, we calculated it as 26. And the speed is here. That's 4 meters per second. So for 26 over 4 would be the time. And that's what, 6.5? And I believe the units would be seconds. At the end of yesterday's soccer game between Team Y and Team Z, Team Y had scored 3 goals, Team Z scored 2 goals. At halftime of the game, Team Y had scored Y goals, and Team Z had scored Z goals. Y greater than or equal to 0, Z greater than or equal to 0. How many possibilities are there for the ordered pair of integers Y and Z? So Z is the Canadian pronunciation, and Z is the, I guess, American pronunciation. That's why I mentioned both. Okay, so for W and for Z, the end result was 3 and 2, right? And then at halftime, we have to figure out what are the possibilities. And obviously, it has to be less than or equal to this end result. And with the parameter that it's got to be greater than or equal to 0. So therefore, it could be 0, 1, 2, or 3. And similarly, for Z, it could be either 0, 1, or 2. So it looks like we have 4 possibilities for W and 3 possibilities for Z. So therefore, the total possibility, ordered pairs, would be this 4 times this 3, which is 12. So 12 ordered pairs would be possible. For how many ordered quadruples, A, B, C, D, of positive integers with D less than or equal to 8 is D equal to the product of A, B, C? So D is less than or equal to 8. So that's good. At least we have a parameter. Okay, let's work through this here. I guess we have to do it for they're positive integers, so I guess we have to do it for everything from 1 to 8. 1, 2, 3, 4, 5, 6, 7, 8. And these are the values for D. Okay, here we go. All right, and then this here, I'll put number of cases as a sort of a tally in this column. All right, and after a while, you'll probably be able to get this yourself, but I'll probably do them all, but let's just see what we get. For when D is a 1, basically we have the scenario where 1 is equal to A times B times C, and the only possibility for A, B, and C would be if they're all equal to 1. So that gives me just one case. If 2 is D, then A, B, C would be equal to 2. And then we have the possibilities as follows. If I were to write it as a triple, it could be either 2, 1, 1, 1, 2, 1, or 1, 1, 2. Correct? So that's 3 possibilities. Very similarly, for 3 equal to D, you have 3, 1, 1, 1, 3, 1, and 1, 1, 3 for ABC. ABC. And that's 3. And similarly, you just keep going. So if ABC is 4, I guess you'd have the standard 1, 1, 4, 1, 4, 1, and the 4, 1, 1. But then you'd also have a 1, 2, 2. That would also do it. 2, 1, 2, or 2, 2, 1. So that gives me 6 this time. For 5, since 5 is a prime number, just like 3 and 2, that would just give me the 5, 1, 1, 1, 5, 1, and 1, 1, 5. So that's 3. All right, we got 6 now. 6 will give me, let's see here, 1, 2, 3. And then its combinations 1, 3, 2, 2, 3, 1, 2, 1, 3, 3, 1, 2, and 3, 2, 1. So that's 6. Is that 6? Hold on here. Yes, but I think I also missed the 1, 1, 6 scenario. That would give me another 3. Yeah, 1, 1, 6, 1, 6, 1, and 6, 1, 1. So actually there's a total of 9. Aha. 7 is a prime number, so that's just going to be the standard 7, 1, 1, 1, 7, 1, and 1, 1, 7. So that's going to be 3. And then 8 is going to be a lot. You're going to have the standard 1, 1, 8 stuff, 1, 8, 1, and 8, 1, 1. And then you're going to have the 2s. There's only the 2, 2, 2 scenario. And then you're going to have a 1, 2, 4, and that will give me probably another 6. 2, 1, 4, 2, 4, 1, 4, 1, 2, and 4, 2, 1. So let's see here, of 6, 7, 8, 9, 10. Okay, so the grand total, if you add up all these guys, let's say we got 10, 20, 26, plus 12, 38. So 38 is the grand total, and that is the answer. In the diagram, ABCDEF is a hexagon with 6 equal interior angles. Also, BC is equal to EF is equal to 6, AB is equal to CD is equal to DE is equal to FA is equal to 2. Line segments, all of those, create a smaller hexagon PQRSTU. If the area of the hexagon PQRSTU is root n over t, what is the ordered pair? NT. Okay, so assuming you got all this, right? You can summarize it on the side if you want, and because I'm going to move it up here because I need the space. All right, so we're going to work with this diagram as best as we can, and let's see what we can do. So first thing, we have 6 equal interior angles, correct? Now the internal angles, because they're equal, this hexagon, I guess I very quickly just draw it on the side here, can be split up, if you do that, into 4 triangles. So the internal angles would all have to add up to 4 times 180, since there's 4 triangles and each triangle has a sum of internal angles of 180. And there's 6 of them, so each would be equal to 4 times 180 divided by 6, and I believe that's 120. So each of these internal angles is 120. So basically what that means is, since this is a rectangle, like for example, that's a right angle, this angle in here would be 30 degrees. So it's so small I can't even put it in there, but you guys understand. I'll create I guess another diagram on the side, but that's the first thing I just wanted to illustrate, because that's very important. Okay, now where do we go from here? I'm going to draw 2 lines. I hope that those 2 lines that I drew in red will help us figure out the area of PQRST. So we got PQRSTU, and did they give us the area or no? Oh, that's the root n over t. Okay, I got it. Okay, so that is this root n over t business. Okay, now the good news is that some of these things we've been told, BC and EF, that was given to us as 6, and A, B, C, D, all that stuff was 2. So I'll just you guys understand. Anything else was given? I don't think so. So I guess some of this stuff I'm going to have to label. So the distance from P to U, or actually I'm going to need another distance here, the top to bottom distance. So that top to bottom distance is what I'm going to need, but I don't have that, so I'll just label that X. And then this distance P to U I'll call Y. So here we go. PQRST we can divide into two triangles. So we have 1/2 base times height, right, for that top triangle PQR, and then the rectangle PRUS, which would just be length times width, and then another 1/2 base times height for the bottom, and that whole thing is this root n over t. Okay, so the base is 6 and the height is x. The base is 6 and the height is y, and the base is 6 and the height is x. So that's the calculation. This becomes, I believe, just 6x plus 6y. So that's actually pretty decent. It's meaningless at this point, but at least it helps. So I think what we have to do is figure out what is the actual value of 6 and y, which I guess you could just factor it. We have to figure out what is the value of x and y. That's what I should have said. And once we do, then we'll be able to figure out what is n and t. Okay, so that's what we do. Now, how are we going to do that? I think there's several ways, but there's one way that kind of pops into my mind is put everything on a coordinate axis. Yeah, put everything on a coordinate axis, and I think that should help. So what I'm going to do is, let me see if I can carefully draw it first, and then I'll explain it. So I'm just going to draw the top half. So for example, this point that I just drew is A, like this, which is representing the origin, and then this point is D, and this is C, and this is B. And because I think the top half is sufficient. Okay, now I need to draw in all the lines. So I think those lines, let me move this up here. Those lines should be sufficient to figure this out. And let me label it here. So this is P, and this is Q. And P, the coordinates, let's call it AB for now, because I need to figure out those coordinates. And then Q, those coordinates, again, I don't know, but let's just call it C and D. And let's see here, what else do I need to do here? One more line. Yeah, that blue line I just put in, that's necessary. Okay, I think that should be good enough. At least I hope so. And okay, so off we go. Now I'm going to have to draw in another diagram, or not a diagram really, but, well, I guess I'll just draw it and you'll understand. So this part of the shape, where this is B, this is A, and this is F. Now that's a very important thing that I need to explain, because this is going to help us. We were told that these are 2, right? But I don't know if you remember, but up top we figured out that angle, these angles are 30 degrees, right? Because this is a 90-degree angle. The internal angles were 120. So if this is indeed 30 degrees in here, right there, let's just put in 30. If I draw a line like that, and like that, that is, I guess, perpendicular, then that means this becomes 60. So that's a 30, 60, 90 triangle. So that means the ratio of the sides would be 2, 1, and root 3. So this side is 1, and this is root 3. Let me see if I, wait, no, I reversed it, sorry. This is root 3, and this is 1. Yeah. So what that means is that the distance from here, A, this guy, to here, is 1. So that means that this P, the x-coordinate is 1. So it's actually 1b. So that's very, very helpful. And anything else we can do here? Not yet. Well, maybe. Actually, yeah, we can. Because we are told that BC is 6, right? So that means C would be 1 plus 6, the x-coordinate, so that's 7. So this is 7 and... Oh, hold on. Oh, wait. Let me see if I did this correctly. Yeah, C is 7 and something. 7 and D. Wait, I know what I did wrong. I'm putting it as Q. That's not here. This is 7 and something. Yeah, that's what I meant to say. And same thing. The B is 1 and something. It's root 3. Okay. I understand why. I should be able to figure this out immediately. Because, see, this is root 3. Okay, got it. And then P would be, the x-coordinate is 1. The y-coordinate I don't have. Okay, got it. And then for Q, where is Q? Q, let me think about this. Well, I think the x-coordinate would be right halfway between. So that would be going from 1 to 7 is a 6, so half is 3. So 3 plus 1, which is 4. Okay, got it. Okay, so we're pretty much there. All right, so let's ensure that we understand this whole setup here. The P is going to be 1b because the distance from A to this point is 1. We figured that out over here with the 30, 60, 90 triangle explanation. And then the Q, that would be 4d. The reason it's 4 is because from this point here to this point is 6 actually. So if you cut that in half, it would be 3, and then you have to add 3 to this 1 there. That's why it's a 4. You got it? And then based on where I labeled the x and the y in this diagram up here, I labeled x and y exactly the same in this diagram. So therefore x would actually be d minus b according to what I have labeled. And the y is going to be, I guess, just the y-coordinate of P, I think. Yeah. And if we need that, we can calculate it. So that would just be 2b, basically. And the reason it's 2b is because it's actually, if you notice, what I have, sorry about that, is actually y over 2, like that. So I have to make sure that I double it. So you got to be a little bit careful when we label the diagrams. Okay, so I think this is workable here. So let's go through with this. How we're going to figure this out is with similar triangles. So for example, if we compare this triangle to this other triangle, it would be 7 over root 3 is the same as the coordinates of P would be 1 over B. So we're comparing the big triangle to the little triangle, and when we solve for this, you get B is equal to root 3 over 7. And very similarly, 4 over D, if you look at the coordinates of Q, if you compare the x to the y-axis, that would be the same as 7 over root 3. You're comparing it again to C. So that would solve to give D as 4 root 3 over 7. So now we can get a calculation for x. D minus B would be 4 root 3 over 7 minus root 3 over 7, which is of course 3 root 3 over 7. And y is 2b, so that's going to be 2 root 3 over 7. And then finally, what do we need to figure out here? Let's see here. Oh yeah, we got to go back here. This guy here. So that means that's 6x plus y. So we have 3 root 3 over 7 plus 2 root 3 over 7. And that's 6 times 5 root 3 over 7. Okay, so I'm running out of space, so I'll just do it down here. So we have root n over t is 30 root 3 over 7, correct? Okay, well, if I bring this into the radical, I'd have to square it first, so 900 times 3, 2,700 under the square root sign over 7. So there you go. So nt is 2,707. A Gleeson list is an increasing list of distinct positive integers with the sum of 2024. For example, 70, 700, and 1254 is a Gleeson list of length 3, and 2, 4, 6, 8, 10, 15, 9, 8, 7, 1000 is a Gleeson list of 7, length 7. Let M be the maximum possible length of a Gleeson list. How many Gleeson lists of length M are there? All right. So I guess the answer would be a certain number of lists of length something. So whatever the number is, we will have to figure that out. So when you have consecutive integers like 1 plus 2 plus 3 all the way until n, there's a formula that a lot of you know. It's n times n plus 1 over 2 when you add up the sum of consecutive integers. So in our case, we are adding a bunch of integers and the sum is 2024. So I'm interested in the maximum possible length, which is exactly what they're talking about here. So what if they're all consecutive, like 1 plus 2 plus 3, like that? If that's the case, it would be n times n plus 1 over 2. And n times n plus 1 is 4048. And instead of doing a quadratic, I'm just going to treat it like n squared, just to get a approximation. And when you do this, you'll get approximately n is equal to around 63 something, point something. So let's see what happens. Let's say n is 63. Then it would be 1 plus 2 all the way up till 63. That sum is 63 times 64 divided by 2. And that is 2016. Okay? We have that as a candidate for n, but let's try what happens when n is 64. Then that would be 1 plus 2 all the way till 64. And that sum is 64 times 65 divided by 2. And that is 2080. So we've gone over. So the max n is going to be 63. So that means the 63 goes here. At least we got one part of the solution. Now we have to figure out how many lists are there. Okay, so let's see what we can do. How many lists are there that have a length of 63? Now, the important thing is that these are in increasing order. I think that's criteria. Let me just double check here. Yes, increasing list. So that's very important. That actually helps us out. It kind of narrows things down. So that means we have 64 terms. Sorry, 63 terms. 63. And when you add them all up, you will, A62, let's just put a 62 in there, you will get 2024. Now, they obviously cannot just be 1, 2, all the way till 63. Because if it was 1, 2, 3, 60, all the way until 63, that would fall short, as we previously saw. It only adds up to 2016. So we have to add, I guess, an additional 8. See, the difference between 2016 and 2024 is an additional 8. So some of these numbers have to be a little bit bigger for the sum to add up to 2024. So how do we do that? I guess that's the heart of the question. So far, to be honest, this is just a setup. Nothing's actually been solved. Okay. All right, so, oh boy, I'm trying to think. Yeah. There's going to be several cases here. So, for example, there's going to be several cases. The first case is if you just have one additional term, and then you can have 2 additional terms, 3 additional terms, and so on. Like that. I think it goes up to 8 because I'm pretty sure the last one would be all ones. And let me explain. Alright, let me just explain the last one first. For some reason that came into my mind very quickly. The last is if you added 1 to the last 8 terms. So you'd have 1, 1, 1, 1, 1, 1, 1, 1. So for example, this 63, A63, instead of being a 63, it would be 64. And then this A62, instead of being a 62, would be 63. And if you did that, then the total sum would go up by 8. Does that make sense? I hope so. So that is one possibility. So that's 8 terms. You see, 8 terms, that's what that 8 means. 8 terms had to be changed, in this case, by increasing each by a value of 1. Or you could just change one term, and that is you just change the very last term by a value of 8. So A63 would go up to from 63 to 63 plus 8, which is 71. And then that would make the total 2024. So that is the summary. And I've got a nice table that summarizes all of this. So here we go. I explained this one here. This top one. This one I've explained. This one I explained. So these are the other ones. So you could have 2 terms that go up by, one goes up by 1, one goes up by 7. Or you could have these 2 terms, these 2 terms, these 2 terms, and so on. So I'll underline the scenarios, and then I guess at the end we have to count them all. So these are each individual scenario that I'm underlining. There we go. So let's count them all. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So 22 is the answer. So if we go back to the very beginning, this is 22. So we got 22 lists of length 63.